Now, whenever we talk about work-related questions, we need to make sure that we rewrite them as a fraction. So we look at how much is done per hour. Now, if they're helping each other, they add together. If they're canceling each other out, then it's negative. And it always equals 1 because that is 100%. So whatever equation we get, it's going to equal 1. So a maid can clean the house in 8 hours. Another maid can clean the house in 3 hours. How long will it take them to do the job working together? Well, we know that our answer should be less than 3. Why should it take less than 3 hours? Because the faster maid, she can do it by herself in 3 hours, right? And if she has a helper, it has to be less. Now, we can't just take the 8 and the 3 and add them together because it doesn't take 11 hours to do this, right? We can't add them together. We have to look at them as fractions, as how much is done per hour. So we've got 2 different maids here. We'll call them maid 1 and maid 2. So the first maid, it takes her 8 hours to clean the house. So if it takes her 8 hours, or him 8 hours to clean the house, how much of the house is done in 1 hour? What fractional part? Well, that would be 1/8, wouldn't it? Right, because you have to rewrite them as fractions. And do we know the time? No, we don't. So in this case, our time is going to be x. What about the second maid? Well, she's quite a bit faster, or he's quite a bit faster. And it takes 3 hours for the other maid to clean the house. So that means he or she can get this done in 1 hour, does a third of the house, right, in 1 hour. Do we know this person's time? No. So it's going to be a what? X. Now, what are they doing? Okay, they are helping each other, right? So this is going to be addition. We put them together. So this we multiply. So we put these together as 1/8x. And putting these together, that's 1/3 x. And what does it equal? Always, always on these work-related questions, it equals 1 because that is 100% or 1. Clean one house. It is always, always going to equal 1. Now, can you finish it from here? Yep, should be able to. What would I need to multiply everything by to clear out my fractions? I'll do one more step. Can someone tell me what I need to multiply here? By? You know, we should know. What do I need to multiply by to clear the fractions? Multiply it all by what? 24. Yep, 24. Yep. Let's make sure we're on the right track here. So we'd multiply it all by 24. And you can finish it from here. Question 9 is similar. Question 9, we have 2 accountants. So we've got an experienced accountant. They can do a tax return in 9 hours. And the novice takes them 12. How long will it take them if they're working together? Well, again, this would be addition because they're going to be helping each other out. And we have an experienced accountant and a novice accountant. The experienced accountant can do these tax returns in 9 hours. So how much does the experienced accountant do in 1 hour? 1/9. What's the time? We don't know, so we'll use an X. What about the novice accountant? Novice accountant's a little bit slower. And the novice accountant takes 12 hours. So rewriting this one, how much does the novice accountant do in 1 hour? Well, it does it 12. And what would its time be? Again, we don't know, so that's going to be a x. Right? So these questions are actually pretty easy. Now we put them together. So we have 1/9 x plus 1/12 x equals 1. Always equals 1. What would I multiply this by to clear the fractions? Can anyone tell me what I would use to clear the fractions? 36, right? Because 36 goes into 12 3 times, and 9 also goes into 36, doesn't it? Okay. So we're going to have to multiply this by what? By 36. Okay, that's going to clear out everything that we need to. Oh, yep, thank you very much. I will get that graded for you. All right, so let's go ahead now and leave that for you to finish. But you should be able to finish that on your own. You should be able to finish it from there. Right. Multiply through that 36. So 36 divided by 9, of course, that'd be a 4. 36 divided by 12, that'd be a 3x. 36 times 1, that's 36. Put them together and finish. Did we have any other questions now out of 1/6? Number 1? Sure. Out of 1/6, we'll look at question 1. Now, what are we trying to find here? Well, on question 1, and this is in 1/6 again, we want to know what numbers are not in the domain. When we talk about numbers that are not in the domain, what does that mean? That means they are numbers that give you division by 0. So it makes the denominator or the bottom half of these fractions 0. Now, we may have to factor to figure them out. So let's look at the first one here. X minus 2 equals 0. Well, what number gives you 0 down below? If I move that over, x equals 2. Okay, so that doesn't work because 2 minus 2 would make it what? 0. Down below, can't do it. What about the other one? Well, it's x plus 8 equals 0. So x equals a negative 8. Again, can't do it because that would give you division by 0. What about the last one? Got a factor. So what's this one? X squared plus 6x, right? Minus 16 equals 0. Should be easy to factor. Put your 1 in. 1 times a negative 16, that's a negative 16. It's a negative, so we know 1 is positive, 1 is negative. You should be able to see that it's going to be 8 and 2. So that would be then x plus 8. X minus 2 equals 0. So what numbers won't work? X equals negative 8. And x equals a what? Positive 2. So which one is the correct answer choice? Well, these are the same, right? Because these two denominators gives you a 2 and a negative 8. This is also negative 8, positive 2. So what's the only one that's going to work here? A. Because this one doesn't work because it has a 0. Same thing here. And 16 is not going to give you division by 0 either. So it should be answer A. And what numbers don't work? Negative 8 and positive 2. Is everyone okay with that one then? Right? And that's finding the number or numbers that are not in the domain. Any others out of 1/6 to look at? Okay? Now, 1/7, we only did a couple of them. We only did 1 through 3. Do we need to look at any of at 1 through 3 out of 1/7? Or do we understand those? Those should have been pretty easy. Right? Those were linear inequalities. Well, if we don't have any other questions, then we'll go ahead and work on 1/7 today. So we're going to finish up 1.7 today. When we look at these in 1/7, we're going to be graphing them. But we also have to check regions, because they flip back and forth on whether it's true or whether it's false. And we only shade the true regions. So these are quadratics. And anytime you have to factor, you've got to make sure that you check the regions. Now, just like we talked about before, greater than or equal to, less than or equal to, those get the brackets. Strictly less than, strictly greater than, those are going to get parentheses. And what do we know about negative and positive infinity? Well, they also get what? Parentheses, right? So make sure you remember that. Now, these are going to require us, in some cases, to factor. And then we have to make sure we put them on the number line, make regions, and check. In some cases, it might already be factored. Like, for example, this one. And what we're going to be doing here is we're going to be graphing these on the number line. So this is our original. This is what we're going to start with. If I replace this with an equal sign, what is it going to look like? If I replace it with an equal sign, it looks like this. And if I gave you this to solve, well, you wouldn't have to factor because it's already done, isn't it? This is our original. I'm just putting a box around it so we don't lose it. But this, what would the answers for this one be? All right, this one has already been factored out. So what would your answers be? Well, they would be x equals 0, x minus 5 equals 0, so x equals 5, x plus 4 equals 0, so x equals a negative 4. Right? It's already been factored. Now, what do we know about inequalities? Inequalities have to go on the number line, and we have to shade. So we now need to put these on the number line, and then we're going to be checking them back in the original, the box part here. So we're trying to graph this. We set it to 0 and we factored. Now put them on the number line in the correct order. So the smallest number is negative 4, and then we've got a 0, and then we've got a 5. So here's what are called our critical points. These are called our critical points, and they're where it switches from true to false. And if I've got 3 critical points, then I have one more region. So in this case, I've got 4 regions. So 3 critical points. Think about a loaf of bread. If you've got a loaf of bread and you slice it 3 places, that gives you 1, 2, 3, 4 sections, right? 4 pieces of bread if you slice it 3 times. So we need to pick a number that's in each region, and we're going to check to see if it's true or if it's false. So region number 1, and I always like to work from left to right, region number 1 is numbers that are smaller than a negative 4. So we need a number smaller than negative 4. Any number will work. You want it to be as easy to work with as possible. So a number smaller than -4, well, I'm going to use a -5. For region 2, I need a number between -4, right, and 0. So a number between -4 and 0, you can use any number in there. How about we use a -3? Because that's in there. Right? It's in between them. What about 0 and 5? We need a number between 0 and 5. Any number will work. So how about 1? 1's in between them, right? And what about the fourth region? We need a number bigger than 5. So how about 6? Now we take each number and we check it back in the original and we see if it's true or if it's false. So it does take a little bit of time to do these. And we're going to start with this -5 because that's our first region, -5. We plug it back in to the original. And we want to see if this is true or false. So we plug in our -5. So that's going to be -5 minus a -5. Right? And then we've got -5 plus 4. So we're just plugging in values for x here. And let's work it out. Let's see what we have. So we have -5. -5 minus 5 makes it a -10. -5 plus 4, that makes it a -1. And when we multiply all these together, 3 negatives, so it stays negative. Multiplying those together, and that's going to be a -50. Now, is that true or is that false? Okay, is -50, is that smaller than 0? It is, isn't it? Right? 0 is bigger. So what would this now be? Would this be true or false? Is -50 bigger than 0? Or smaller than 0? Yes. So that would be true. So that region is true. Now we do the next region. Most of the time, they will switch back and forth. But you always have to check, because in some cases they may not. So you always have to check them all. So plugging our values in, we've got -3, and then we've got -3 minus 5, and then we've got -3 plus 4, and that's supposed to be less than or equal to 0. -3 minus 5, that makes it a -8. -3 plus 4, well, -3 plus 4 is a +1. Double negative makes it positive. 3 times 8 is 24. And is 24 smaller than 0? No. 24 is not smaller than 0. So then that one is false. Now we still have to do the other two regions, but normally, not always, but most of the time, they're going to go true, false, false, or false, true. They'll switch back and forth, but not always. So you do need to make sure you check. The next one we're going to check is this 1. So we're going to plug in a 1. And we're going to plug that into x times x minus 5. X plus 4 is less than or equal to 0. So that's 1. 1 minus 5. 1 plus 4. So that's 1. 1 minus 5 is a minus 4. 1 plus 4 is a 5. Now, when I multiply those together, what does that give me? A single negative makes it negative, or keeps it negative. So we've got -20 is less than 0, and that would be true, wouldn't it? And that piece up here is going to be true. We do our last one, right? Just make sure you notice that middle one was true. And what about the last one? The last one, we're going to pick x equals 6. So we've got our equation, or sorry, inequality here. And we've got 6 times 6 minus 5. 6 plus 4 is less than or equal to 0. So that's 6. 6 minus 5 is 1. 6 plus 4 is 10. That comes out to be 60. And is 60 smaller than 0? No, that is false. So that means this half is false. So is everyone okay with what I'm doing? It just takes a little bit of time, and it's either going to be true or false. Now, most of the time they switch back and forth, but not always. So you have to check each one. Most of the time you're only going to have 3 of them to check, 3 different regions. This one happens to have 4 because you didn't have to factor it. So you had to check all 4, but most of the time you just have 3. Now we've got them all labeled. So let's go back up and look at my number line. My answer is going to be where it is true. So where is it true? Now remember, we need, because of our original here, less than or equal to 0. So we're going to need square brackets. So this part is true, and it goes back to negative infinity, and it is also true in the middle. So how would I write my answer now? Let's over to the side, write up the answer. Well, the answer would be negative infinity, because infinity always gets parentheses, comma, negative 4 with the square bracket. Where does it go to? We use a U for union. 0 to 5, also with square brackets. So that would be your answer. You just write up what is the true part. Now, this one had 4 regions. Most of the time, you're only going to have 2 regions. And they're going to be pretty easy to factor. So let's do a couple more of these. Let's look at this one. And what we're going to be doing here is we're going to be solving and graphing. And then we'll write our answer in interval notation. So let's look at this one. How about we do a simple one? How about x squared equals 16? Or sorry, is let's say less than or equal to 16. Okay, this needs to be an inequality. So x squared is less than or equal to 16. What I always like to do is box it, because this is what we start with. And we've got to make sure we know what we started with so we can check. Now, if I replace this with an equal sign, you should know how to solve it. If I replace that with an equal sign, how would you solve x squared equals 16? Square root. And whenever you take a square root, you have to make sure you add in a what? Plus or minus. Okay? So that gives you then x equals plus or minus 4. So that's x equals 4. Okay? And x equals a negative 4. Put these on our number line. And this makes regions. So region 1, region 2, region 3. check each region. Now, what numbers are we going to use? We're going to try to pick numbers from each region. So this one, region 1, we need numbers that are less than -4. Well, a number less than -4, we could use a -5, easy. A number between -4 and 4, make it as easy as possible. How about 0? And then we need a number that is bigger than 4. So how about we pick 5? 5 is bigger than 4. All you need is a small number in each section to check. Now, we go back, and where do we check them? We check them back in our original. We check them back in this one. So let's check x equals -5. And we want to see if this is true or false. Well, -5 squared, what is that? -5 squared, when you square a negative, it becomes a positive. And so is 25 bigger than 16? Yep. So that means this is true. Now, the middle should be false, but let's check it and make sure. So let's pick 0. That's easy. 0 squared is greater than or equal to 16. Well, 0 squared is 0. Is 0 greater than 16? Is that true or false? Is 0 bigger than 16? No, it is not. So that is false. What about, and that was region 2. What about region 3? Let's check 5. Well, 5 squared is what? 25. And is 25 bigger than 16? Yes, it is. So that's true. Now, where do we shade? True regions. And if we go back up and look, it is greater than or equal to. So that means we need square brackets. So it looks like this. Negative infinity, positive infinity. And what does my answer look like? In interval notation. Well, in interval notation, it looks like negative infinity, comma, -4 with the square bracket. We use a U for union. And that's 4 to positive infinity. So is everyone okay with how we're doing these? We solve it. Whenever it's nonlinear, we solve it. We find our values, which are the critical points. We put them on a number line, and we check each region. Let's look at this one. Again, solve and graph. So this is what we're going to start with. And let's make that a -25. That way it works. So it should be a -25 there. So I want you to work with this one. We're going to graph it. Now, think about this as an equal sign. If I gave you x squared minus 10x equals a -25, how would you solve this one? Well, if it's an equals, you need to set it to what? 0, right? You've done that numerous times. So let's add that 25 over. And this happens to be a perfect square trinomial, because 25 is a perfect square of 5. First times the last is a 25. And what two numbers multiply together to give you 25? Add together to give you a -10? Well, that's going to be easy. That's going to be what? negative 5, and negative 5, right? Because 25 is a perfect square of 5. So that factors now into x minus 5, and an x minus 5 equals 0. Okay, so that gives you x minus 5 equals 0. So x now equals what? X equals 5, right? We only have one critical point in this case, so that means we only have to check 5, and that's going to be it. Because they're both the same, so you only have one value to check. So we have one value, which that means 2 regions. So we need a number smaller than 5. How about 4? And we need a number bigger than 5. How about 6? And we'll see if it's true or false on these. What are we going to check it back into? We're going to check it in the original. In the boxed version, clear up here. So this is what we're going to check it in, and we'll just check the 4. That's over here in region 1. So we'll check the 4 first. 4 squared is 16. A minus 10 times 4, that's a minus 40. And minus 16, positive 16 minus 40. That makes it a minus 24. And is minus 24, is that bigger than a negative 25? Yes, it is. Okay, watch your signs. Make sure you're careful. That would make that side true. This is why you have to check both sides. What about the other side? What about x equals the 6 here? If I plug in the x equals 6, let's see what happens. This is why you need to check both. Because 6 squared, that's a 36. 10 times 6, it's a negative. So that makes it a minus 60. 36 minus 60. Well, that makes that a minus 24 again. And is minus 24, is that bigger than a minus 25? Yes, it is, isn't it? Now look at your number line. What do you notice about the number line? When I look at the number line, we want where it's true. Well, if I look at where it's true, what does it cover? It covers the entire line, right? Because all of it's true. So what would your answer be? The answer would be negative to positive infinity. What would have happened if these would have both been false? Well, if they would have both been false, then you would have what? No solution, right? So if they're all true, it covers the entire line. They can be broken up into pieces like the others. Let's do one more. This one's going to have imaginary numbers. Well, let's just do greater than. It doesn't matter. We'll just do greater than negative 4. Okay, now this is kind of like your homework. There's a question like this one in your homework. I always like to put a box around the original so I don't lose the inequality. And we have covered these before. How would you solve this? What technique would you use? Square root property, right? You're not going to FOIL it out, are you? Nope. Take the square root. Now, why is it important that you be careful with the signs? Well, when you take the square root, plus or minus, but what happens with that negative 4 underneath? careful with the signs. We know the square root of 4 is 2, but it comes out as an I, doesn't it? Moving that over, move that 1 over, and now we've got this. So x equals minus 1 plus or minus 2i. Now, how is this one different from all the others? Well, this one is different from all the others because when we look at a number line, okay, if I look at my number line, do I have imaginary numbers on this number line? No, it's only real. So it's only real numbers on the line. So if it's only real numbers on the line, then it is either always true or always false. So if you get complex numbers like this one, non-real numbers, it's either always true or always false, and we need to check. What it means is basically it can't switch between them, because the numbers that we find are where it can switch from true to false, back and forth. Okay, so in this case, we need to see if it's always true or always false. Now, you can pick any number that you want. It doesn't matter. I usually pick 0 because that's easy to work with. And I'm going to go ahead and pick x equals 0. There it is on the number line. And let's see if this is going to be true or false back in the original. If I plug in that 0. Well, what happens when I add them together? I get 1. 1 squared is 1. And is 1 smaller than a negative 4? Is that true or is that false? This would be false. Now, it's either always true or always false when you have no critical points. So in this case, it's going to be what? All false. Okay, so that means your answer would be what? The empty with a null set, because it's all false. So whenever you get a non-real number, it's either true or false. Pick any number that you want. I chose 0. You could have used a negative 1,000 if you wanted, but why make it more difficult than what it needs to be? 0's easy, so I usually pick 0. You could pick 1 or 2 or whatever you want. Plug it in, see if it's true or false. If it's true, it's everything. If it's false, it's nothing. So again, anytime you get imaginary numbers like this, they can't go on the number line. So it's either true or false. And you could have even thought about it in a more abstract sense. Because what do we know about numbers when we square them? When we square a negative, what does it become? Whenever we square a negative number, it becomes positive, doesn't it? So I could have looked right here at the very beginning. This side is always going to be positive or 0. Because when you square a negative, it becomes positive. Smallest it could ever be is 0. So if this is positive, are positive numbers going to be less than a negative 4? Is that true or false? Are positive numbers smaller than negative 4? That would be false, and that's why it never works. We went through and actually did the math, but you could have looked at it at the very beginning and thought about it with the square, because whenever you square a negative, it always becomes positive. And then say it's positive numbers, if they are less than negative 4, that would be false. So you'd have no solution. Let's go ahead now and look at rational inequalities. And these have a special way of solving them. We're going to look at rational inequalities. And these are the fractions. And we solved these back in 1-6. Right? When we looked at rational inequalities, we solved them. And there's a step-by-step set of directions. Step number 1. Find the numbers, or numbers, not in the domain, division by 0. And they are always going to have parentheses. Okay, so you want to find the number or numbers that are not in the domain. And when we go to graph these, which we will be doing, they're always going to have parentheses. Step number 2 is you clear the fractions. And solve. Now, these can have either brackets or parentheses. So parentheses, 4 less than or greater than, square brackets for greater than or equal to, less than or equal to. So step-by-step procedure. First thing we do is we find what numbers don't work. We label those. Those are always going to get parentheses. Then we clear the fractions and solve it. Now, once we have done that, they're either going to have brackets or they're going to have parentheses. That's going to depend upon the inequality. And now we put them on the number line and check. So place them on the number line and check. So just like we've done before. So we'll start off here with a really easy one. And again, we're going to be graphing and solving these, and I just say graph it, but you're actually solving the inequality. Let's say I give you this. How about 4 over x plus 3 is less than or equal to 1. Okay, so first off, it's an inequality, so I know that I have to eventually graph it. So I'm going to put a box around it, and the only reason why I put a box around it is so I can keep track of it. It's easy to lose things, so I like to put a box around it. That way I know where it's at. Now, what's my first step say to do? My first step says to figure out what numbers or numbers are not in the domain. So what is not in the domain? Well, what's not in the domain is going to be x plus 3. That's my denominator, equaling 0. And we can solve this pretty easily. Move that 3 over. So what number is not in the domain? Well, that's a negative 3. And since it came from the domain, it is going to get parentheses. Okay, so there's that piece. Now, what else do we need to do? After we found the number that's not in the domain, now we need to clear the fractions and solve. So what do we have? We have 4 over x plus 3, and that's going to be, we replace that inequality with an equals. All right, make it equaling 1. Pretty easy to do. How would you solve this out? Well, I need to clear out my fractions. So I'm going to make this over 1, and I'm going to then cross multiply. And cross multiplying, that gives you 4 equals x plus 3. And we'll move that 3 over. So now we've got x equaling now 1. And because the original inequality was less than or equal to, it's going to get a square bracket on the line. And so the ones that are not in the domain, they always, always, always get parentheses. The other one can either be brackets or parentheses, depending upon the inequality. Now, we put these on our number line, just like we've done previously, and we check them. So we've got -3, and we've got 1. That makes regions again. So how about we pick -4 for the left-hand side? How about we pick -2? It's in between there. You could have also have picked 0. It wouldn't matter. And number bigger than 1, how about we pick 2? Okay, now we'll go ahead and check them. So we're going to check x equals -4, and we're going to check that in. 4 over x plus 3 is less than or equal to 1, so plug it in. That's 4 over -4 plus 3. And -4 plus 3, that's a -1. And that's then a -4. And is -4, is that smaller than +1? Is -4 smaller than +1? Yes. So that means this piece would be true. Now, it should switch back and forth. But again, you have to always check, because there are some cases when you have multiple roots, they can switch and be true, true, false, or false, false, true. So you always have to check. -2. Okay, we're going to check back in our original again. And that's going to be 4 over -2 plus 3. -2 plus 3 is a 1. So that's going to be a 4. Now, in this case, is 4 smaller than 0? Or sorry, no, let me say it right. Let me say it so it's correct here. Is 4 going to be smaller than 1? Is that true or false? Is 4 smaller than 1? No. This would again be what? False. So that means that middle is false. This first one is true. Okay, and we need to do the last one. We're going to now use a +2. And let's see what happens with a +2. If I use a +2, then I get 4 over 2 plus 3, right, because I'm just plugging the 2 in, is less than or equal to 1. Well, 2 plus 3 is a 5. What do we know about 4/5? If we use our calculator, what's 4/5? If you need to, you can use the calculator here. 4/5 should be 0.8, isn't it? Right? Divided by 5 is 0.8. And so now is 0.8, is that less than or equal to 1? Is 0.8 smaller than 1? Yes. So that means this part is also true. Where do we now shade? When we go back up, we shade here. We shade over here. Now, what do we know about the 1? 1 gets square brackets. And what about the -3? We go back up and look. -3 came from the domain, so it gets parentheses. And what does the answer look like now? I'll try to write it over here so I keep it all on the same screen. Well, the answer now, we want the true parts. So the answer would be -infinity to -3, parentheses. We use a U for union, 1 to positive infinity. Okay? And that's your answer. So that's all you need to do there. That should now let you finish 1.7. Okay, we should be able to cover all of 1.7. We've got enough time now to work through at least part, if not all, of 1/8. And so let me just kind of give you an update on when our next exam will be. So as you can tell, 1/8 is the last section of this chapter. So on Tuesday of next week, we're going to finish up 1/8, start reviewing for our exam, work on that practice exam. And so our next exam will be next Thursday. So a week from today will be our second exam. We're going to get through most of 1/8 today. Not all of it, but most of it. And 1.8 is absolute values. Now, when I look at absolute values, we'll do the equations today, and we'll do the inequalities on Tuesday. But when I think about absolute values, I need to get the two solutions. So let's just look at one that we can just look at and solve. Does anyone want to tell me what two numbers would work here? Well, absolute value of x equals 9. Well, the two numbers are going to be 9 and what else? Someone said it. -9, right? Why do we have two answers? Because what's the absolute value of 9? +9, right? What's the absolute value of a -9? Well, that is also what? +9, right? Why do we get 2? Because an absolute value. Because an absolute value is going to make that negative number a what? Positive. So when we solve absolute values, we get two equations, and that gives us two answers. So let's solve a few of these. So here's an easy one to work with. So I want you to solve this absolute value. Now, whenever I solve an absolute value, I've got to get my two answers. Okay? So that means I build my two equations. So what do my two equations look like? Well, the first one, we just simply drop the absolute values. So that's going to be 3x plus 5 equals 4. And the other one, we just switch the right-hand side. So the other one would be 3x plus 5 equals a -4. Two equations, two answers. Now let's finish it, and we'll do each one, and we'll get our two solutions here. So move that 5 over with subtraction. So 3x now equals a -1. We'll divide by our 3. So x equals a -1/3. So there's one of them. What about the other one? Move the 5 over. 3x now equals a -9. We'll divide by our 3. And so x now equals a -3. So there's your two solutions. Now, they don't have to be one positive and one negative. They can both be negative. They can both be positive. Or they can be one of each. So don't think that you did it incorrectly because they're both negative. That can happen. And that's why I picked this one, because you'd see that when you solved it, they are both negative, and that's okay. That can happen. Not all the time, but it can happen. They can also both be positive. Let's try another one. Now, this is a commonly made mistake on these. When you go to solve this, you have to have the absolute value by itself on the left. So only the absolute value is allowed to be on the left. So let's go ahead and move that 9 over with addition. And that is then the absolute value of minus 7x plus 6 equals 5. Okay. Now we should know what to do. And I picked this one because here's another commonly made mistake. Do not change what's inside. So what is inside my absolute value is minus 7x plus 6. That's going to equal a 5. So we just drop the bars. The other side is the same. Minus 7x plus 6. Notice it stays negative, right? Do not change that. But what does it equal? Negative 5. Move that 5 over. So the absolute value must be on the left. Let me write that over to the side here. So the absolute value must be on the left by itself. So that absolute value has to be on the left by itself. Ready? Yep, I can stay up for you. You skipped 2 questions, right? Okay, all right. Get that graded for you there. Okay, thank you very much. And I'll probably work on grading it this afternoon. So now we're going to solve it, and we're going to get our 2 answers here. So let's move that 6 over. And that's going to give you a minus 7x equals a minus 1. Be careful with your signs. Divide by a negative 7. And now we have x equals 1/7. So there's one of them. And we do the same on the other side. Move that 6 over. And we've got negative 7 equals now 5 and 6 makes it a negative 11. Divide by your negative 7. And so in this case, it's a positive 11/7. So there's my other. You may get no solution. And how can you get no solution? Well, what do we know about absolute values? Whenever I take the absolute value of a number, it always comes out to be what? Positive or 0. Can you ever have it equaling a negative? No, because what happens if I take the absolute value of negative 12? Okay? Absolute value of negative 12 is positive 12. Absolute value of 10 is positive 10. The smallest it can ever be is 0 because the absolute value of 0 is 0. So, if I gave you something like this, how about the absolute value of x plus 4 equals a negative 9? Can that ever happen? No, because absolute values must be positive, and can positive numbers ever equal a negative 9? No. So that has no solution. We're going to do several of these just to make sure that I reinforce that concept. Okay, what about this one? Absolute value of 3x minus 15 plus 9 equals 2. Well, this one may look like it can work. Oh, did I? On how I did this one? Okay. I don't have to solve this. Why? Because we already know that absolute values are what? Positive or at smallest 0. So can it ever equal a negative 9? No, So that's why this one has no solution. Because the right-hand side over here is negative. You can't have that. So it has no solution. Now, what about this one? This one looks like it might have a solution, right? But what happens when I move that 9 over? It makes the left-hand side equaling a -7. And let me just write it out so you see here. Since it is -7, it has no solution. Okay? So if, when you move it over, that right-hand side is negative, it has no solution. Thank you, Jack. Did you finish it, or you want to come back after lunch then? Okay, yep, I'll get it ready for you. Okay, so that has no solution. Another one. Minus 3x plus 4 equals a -12. Do I have to solve this one? No. Why do I not have to do any work at all? Because that is negative. So since it is negative, what does that give you? No solution, right? So always make sure when you look at these, if it equals a negative number on the right-hand side, it has no solution. What about 0? Okay, we've just got a couple more minutes here. Can we solve 0? Yes, we can. This one, though, would only give you what? One answer. Because you can get 0. How can you get 0? Absolute value of 0 is, of course, 0. So, what's my equation look like? 4x plus 1 equals 0. Move that 1 over. So 4x equals a -1. Divide by your 4. And that means then that x equals now -1/4. So 0 you can solve, but there's only one solution because it doesn't have a negative part. And the last ones that we're going to look at are what happens when we have an absolute value equaling another absolute value. So I'll go ahead and pass out the sign-in sheet. And this will be our last question today. Make sure you sign the sign-in sheet. Now, this will be our last question for today. And we're going to solve now the absolute value of 3x plus 4 equals the absolute value of 5x minus 2. Okay, so it won't take long at all for us to finish this one, and this will be our last question, and then we'll talk about the homework. Now, what do we have? We have an equals, right? Whenever we have an absolute value, we've got to get two solutions. That comes from two equations. So what are my two equations? The first one, we drop the bars. So it's 3x plus 4 equals 5x minus 2. So all I did was I just dropped my absolute value bars. What about the other one? Well, the other one, I make the right-hand side negative. So the other one is going to be 3x plus 4 equals, you put a negative in front, parentheses, 5x minus 2. You have to put the negative in front because it has to be distributed through. So let's go ahead now, solve this out. So solve each of these, move that 5x over, and move that 4 over as well. So 3x minus 5x, that leaves it a minus 2x. 4's cancel, the 5's cancel. Minus 2 and minus 4 makes it a minus 6. We'll divide by our negative 2, and that leaves me then with x equaling what? 3. So there's one of them. What's my other solution going to be? Well, for the other one, we've got to distribute that negative through. So do that first. So 3x plus 4 equals a minus 5x. Negative and negative makes it a positive 2. Now we can finish it. So move that 5 over with addition. And move that 4 over with subtraction. 3x and 5x makes it an 8x. The 4's cancel. 5x is cancel. And 2 minus 4, that makes it a minus 2. Divide by our 8. And what's my final answer for this one? When I reduce, x equals a negative what? 1/4. What's our homework? Well, for our homework, you should be able to do all of 1/7. So 1/7, you can do them all. 1.8, well, 1.8, we can do quite a few of them. 1.8, we can do 1 through 4. So we can do those. The inequalities we'll cover next time. So 1.8, you can do 1 through 4.